Hi students, this is Miss Rosie. I wanted to speak to you a moment about our order of operation. On the video, the YouTube video, it did not have something that I like to use in order to remember what order I'm supposed to do different expressions, which are our math expressions. And that thing is called PEMDAS. PEMDAS. P stands for you do parentheses first, and on the video it says parentheses and brackets. E, you do exponents. That would be, if it was 10 to the third, all you do is make sure you have the 3 zeros. Okay? That is an expression, or an exponent. Then M is for multiplication. You would do multiplication then. D is for division. A is for addition. And S is for subtraction. They made this parentheses and brackets, this exponents. They combined multiplication and division, and they combined addition and subtraction. So you have to, whatever the operator is, the division, or if there's parentheses, or if there are exponents, okay, you do this first, you would do this second, and you do this third. So make sure you remember PEMDAS and what it represents. Now we're going to get to our lesson for today. We're starting with Chapter 1, and with Chapter 1 we're going to be talking about factors, primes, and composite numbers. Factors are the answers to multiplication problems. Product is. So we have multiple factors. We could have 4 times 5 times 3, etc. These are all considered factors. And then our answer would be the product. So make sure you're familiar with these terms. But we're going to be learning the factoring tree, and I know you've had this lesson because I taught it for Miss Alexander when she was absent one day. So the primes and composite numbers. The first 10 prime numbers, and a prime number is only one in itself, that will, and nothing else will go into it, no other factors. So the 10 that I want you to remember are 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. Okay, I'm getting smaller as I go up. After 23 is 29, so let me push the recorder over. Okay? Remember these 10. And when you're doing your factoring tree, if you get it down to any of these 10, you can't go any further. So you have to know these 10 prime numbers. A composite number is 2 or more numbers will go into it. For instance, if we have 4, 2 times 2 equals 4. Okay? So but if we had just 2, it would be 1 times 2. This is prime. And this is a composite number. I'm just going to abbreviate. So if it has 2 or more, other than itself and 1, 2 or more, it's considered a composite number. Now, what are we doing with the number 1? 1 is neither prime nor composite. So if I give you the number 1, It is not prime and it's not composite. It's neither of those. But let's go over our first 10 or our first 5 prime numbers. Again, getting them to these numbers, you can't go down any further. 2, 3, 5, 7, 11. Okay? Keep saying those. 2, 3, 5, 7, 11. Whoops, I'm going the wrong way. 2, 3, 5. Think of the store 7-Eleven. Then we have 13, 17, 19. 3 more teens. 13, 17, 19. Then 2 of the 20s, 23 and 29. Are these all the prime numbers? Absolutely not. But this is where your divisibility rules come into effect. Remember, 2 on our divisibility rules, if it ends in an even number, starting with 0, all the way up to infinity, just like Buzz Lightyear says, then it is divisible by 2. And 2 is a prime number. I don't know why I erased those. 2, 3, 5, 7, 11, 13, 15, 17, the 3 teens, 19, I'm not 15, I'm sorry, 13, 17, 19, our 3 teens after this, 23, and 29. Okay, and you may want to put those on top of your paper before you start doing your factoring tree. But just going over the divisibility rules, 2, if it ends in an even number. See if it's a little bit bigger on this page. 5, if it ends in a 0 or 5. It's divisible by 4 if the last 2 numbers are divisible by 4. For instance, 20, that would be divisible by 4. But 4 is not one of our prime numbers. So we want to kind of always get down to our prime numbers. 3, the sum of all the numbers. The sum of these is 9. So this 342 would be divisible by 9. Why? Because the total of these equal 9 and then we know that 9 is divisible by 3. It's divisible by 9 again if they all add up to a number divisible by 9. That means just like this, but of course if we have 2 plus 1 equals 3, that is not divisible by 9. Why? Because 3 is not a large enough number. However, this would be divisible by 9 and divisible by 3. It's divisible by 6 if it's divisible by both 2 and 3. Keep those divisibility rules and your first 10 prime numbers handy. When you're doing these problems, it'll help you so much more. But you need to have these memorized before you get into 6th grade. So if you want to get into 6th grade, you keep these memorized even through the summer. But we're going to be starting on lesson 5.1, factors, primes, and composite numbers. Okay. Lesson 5-1. Can you guys see that? Bring it over a little bit. All right. We've already talked about what factor is. It is the numbers multiplied together to get product. We've gone over composite numbers, which are forever. They are the ones that have 2 or more factors that are divisible into that number. And prime numbers is 1 in itself is only divisible into the number. So let's try the number 48. Now, when you are doing the factoring tree, remember the factoring trees, you need to make sure that the next two numbers equal the one that it's pointing to, the branch that's going up to it. So they can be different. I can do 2 times 24. That gives me 48. When it is a prime number, circle it. That means you don't need to do anything else with it. It's dead. Then I can do 24. Again, there are several ways I can do this. It could be 3 times 8. It could be 4 times 6. Let's do 4 times 6. Neither one of those are prime. So I've got to branch down again. 2 times 2 is 4. And 2 times 3, is 6. You want to put the smallest number first if at all possible. So for factoring, we have 1, 2, 3, 4 times 3. I have 1, 2, 3, 4 2s, and then a 3. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. Multiply it back to make sure you get the same number. Okay, let's do this a little bit different. We do 48. We can do 6 times 8. 6 8s are 48. Neither of those numbers are prime numbers. Look up here. So we need to branch off again. 2 times 3. And then 8 is 2 times 4. This 2 is prime. 4 is not a prime number. Okay, so we branch off again. 2 times 2. So all of our factoring that we have circled are prime numbers. Again, we've got 1, 2, 3, 4, and a 3. 1, 2, 3, 4. Yep. 3 2s are 6. Again, multiply it back. 12, 24, 48. That's how you do your factoring tree. Okay. If you do not have this written down, write it down now. I'll give you a second to write it down because that's going to help you with your homework. Okay, let's go to the number 48 again. And we had 2 times 2 times 2 times 2 times 3. You can also write this to where it's more compact. So we could also say 48 is 2 to the 4th power times 3. Now you can make the little dot or you can put your X, whatever you want. Don't make your X as large as your numbers. And how did I get 2 to the 4th power? It's because I have 1, 2, 3, 4 2s. So that's 2 to the 4th power times 3. These are called exponents, exponential power. As a matter of fact, on your homework that we're going to be doing, you need to convert them, you need to factor them, and then you need to convert the answers to exponential powers, if there are any. If I had 3 times 5 times 5, put them in order, least to greatest. Okay, because if you put 5 times 3 times 5 times 2, that's just a mess. So you need to put them in order. This one, when I changed it after I factored it, I would have 2 times 3 times 5 squared because I have 2 5s. That means it's not 5 times 2. It means it's this number times however many these are. So 5 times 5 is 25, not 10. All right, let's do another number. Let's do 72. Now, hopefully with you learning your multiplication tables, you should know that 8 times 9 is 72. Okay, I'm putting my 8 first. 8 times 9. Neither of these are prime numbers. We've got to keep going down. 8, we have 2 times 4. This 2 is a prime. We can go up here and do it, or you can finish this. It's 2 times 2. Okay, 9 is 3 times 3. And those are prime. So I have, to get 72, I have 2 times 2 times 2 times 3 times 3. 3 times 3 is 9, 9 times 2 is 18, 18 times 2 is 36, and 36 times 2 is 72. You may need some scratch paper to multiply that back. When we answer it, this would not be my final answer. My final answer would be 72 is 2 to the 3rd power times 3 squared. Because we have 1, 2, 3 2s, and we have 2 3s. So this would be my final answer. Make sure when you do your homework you give me this type of answer and not this, or it will be incorrect. Okay, we'll do a couple more, and then I will assign you your homework. Okay, let's do a bigger number. 270. Wow, that's a big number to be factoring, but don't let it bother you. We know that it's divisible by 2 because the end is an even number, 0. It's divisible by 5, and it's divisible by 10. Okay, so let's do 10 times 27. Okay, 10 times 27 is 270. Neither of those are prime, so we're going to go and branch off of our 10. We're going to make him 2 times 5. Both of these are prime numbers, so we don't go any further than that. 27 is 3 times 9. 3 is prime, 9 is not. So we have to branch down on our 3 again. 3 times 3. So for 270, I have 1, 2 times 3 of the 3's, 1, 2, 3, times 5. You say, Miss Rosie, why is it important to put it up here? Well, first of all, to multiply it back to make sure you have that correct number. And when we start doing least common multiple and greatest common factor, you're going to need comparisons. So you need to learn to put them in least to greatest, and you need to do it neatly. So our final answer for 270 is 2 times 3 to the 3rd times 5. Whoops, we forgot to count this back. 5 times 3 is 15. 15 times 3 is 45. 45 times 3 is, okay, now I'm going to have to multiply that. 15, 12, 30 is 135. 135 times 2 is 270. Okay, so it's what we started with. I hope this is simpler for you. Remember your divisibility rules. Review those before you do this, and make sure you have these first 10 prime numbers. Okay, first 10 prime numbers. So I don't want you to write them on your paper and say, oh my goodness, what are those numbers even for? Okay, so first 10 prime numbers. Okay, your homework, and I will put this out there on LMS. And this will be due Friday. You are to do page 98, okay, lesson 5-1, page 98, number 1 through let's do 1 through 16. Let's do 2 through 16 even. Okay? 2 through 16 even. Remember, if you need any help, you can call me at 321-750-7861. If I do not call you back immediately, it will be soon after. So don't hesitate to call. I want to be able to help you. Thank you, and you have a blessed day, students. I miss you very much. Bye.